Alright, hi you guys. This is Miss Evangelista, and this is video 4.1, Properties of Rational Functions. Our objective for this video is that students will be able to determine the horizontal asymptotes, vertical asymptotes, x-intercepts, y-intercepts, and domain range of a rational function. Okay, go ahead and pause this video and copy this slide. You need to make sure that your notes are titled video 4.1 and the objective needs to be copied. So let's start by talking about what a rational function is. Hopefully this is somewhat of a review, as you should have learned this in Algebra 2. Okay, now in layman's terms, what a rational function is a function that's a ratio of two polynomials. Okay, so it's any time that I'm dividing a polynomial by another polynomial. So here is an example of a rational function. If you want a more technical precalculus definition, we could take any polynomials n of x divided by d of x. Okay, now this would constitute a rational function where obviously d of x, whatever's in the denominator, cannot be 0. Alright, so what does the graph of the parent rational function look like? Remember, the parent rational function or parent function is the simplest, most basic form of any function. So in this case, for our rational functions, it's the equation f of x equals 1 over x. Go ahead and take your calculator and type 1 over x into the y equals button and graph this. Pause the video and do that now. Okay, here's what you should get. Now, if we're looking at this graph, what do you notice about this graph in general? Okay, one thing that you should notice is that each branch of this graph seems like it's approaching certain values. Okay, so if I look at this left side of this branch, okay, looks like these y values are getting really close to the x-axis. But do they actually ever touch the x-axis? No, they don't. Now what about over here? Okay, what about over here? Does this graph ever touch the x-axis? Well, think about it. If it were to touch the x-axis, that means that we would have x equal to 0. Is it possible for us to have x equals 0 for this graph? Think about it. I want you to think back to the original function. If we took that denominator and set it equal to 0, we would have 1 over 0. And guess what? You know it. It's undefined. Okay? So x cannot equal 0 in this case. Okay? Now, what do we call that vertical line that the graph gets horizontal line that the graph gets really close to but never touches? Well, it's an asymptote. And now this asymptote is a horizontal asymptote because it's a horizontal line that the graph gets really close to but never touches. And in this case, it's y equals 0. That's important to remember when you're writing the equation of a horizontal asymptote. It is the equation of a line. So you must write y equals and whatever it equals. Okay, so that's for a horizontal asymptote. If we're looking at the vertical asymptotes, looking at this graph, as y approaches infinity, as the graph keeps going up and up and up, it looks like this graph gets really close to that y-axis. Okay, and what we'll find here is that it, again, just like the horizontal asymptote, will never actually touch that y-axis. So here again, we have another asymptote, but this time it's a vertical asymptote because it's a vertical line that the graph gets really close to but never touches. Okay, so that is our vertical asymptote, x equals a. And in this case, our a, our constant, is 0. Okay, now we were able to determine the horizontal asymptote, vertical asymptote, x and y intercepts from just looking at the graph. X and y intercepts, just real quick. If we have asymptotes on the x-axis and the y-axis, does the graph ever actually touch the x or y-axis? No, which means that we, in this case, would not have any x-intercepts or y-intercepts. Okay, now going back. How could we find this information if we were just given the equation, so without looking at the graph, okay? Well, there's a couple of steps that we can follow that will always help us find this key information. What I want you to do is pause this video and copy this table. So you need 6 columns, 1, 2, 3, 4, 5, 6. Title each column as I have them here, and then in your first row or your second row, write rules. Go ahead and pause the video and copy this now. Okay, we're back. Let's start by finding the vertical asymptote. The vertical asymptote can be found by setting the denominator equal to 0 and solving for x. Okay, now feel free to pause the video as you need. Let's think back to our parent rational function, right? This was 1 over x. Here, 1 over x. Our vertical asymptote was found by setting the denominator, which is x, okay? Our denominator was x, and we set it equal to 0. So that was the equation of this vertical asymptote, okay? So that's how we're going to find vertical asymptotes. How do we find horizontal asymptotes? Well, to find a horizontal asymptotes, we have to look at 2 things, and this is where this column is going to come into play, okay? Now, num degree, this stands for the degree of the numerator, okay? So num degree is the degree of the numerator, okay? And you can probably guess den degree is the degree of the denominator. Now, you might be wondering, well, what is degree? If you recall, degree is the value of the highest exponent. So we're looking at the value of the highest exponent in the numerator and in the denominator. Okay. Now, to simplify this a bit, I'm going to call the degree of the numerator n and the degree of the denominator d. Okay. Now, there's 3 cases that are possible here. The first case is this example here. Okay, if we look at, go ahead and copy this so you have an example. F of x equals x squared minus 1. Well, the degree of the top here is what term, first of all, has the highest exponent? I hope you're saying x squared. Okay, now what is the exponent? It is 2. Okay, so my n, the degree of the numerator, is 2 in this case. And the degree of my denominator is 1, because I know x, we don't have to write the 1, but we know that it's 1. So in this case, we see that the degree of the numerator, n, is greater than the degree of the denominator, okay? So n is greater than d, and we call this top heavy, okay? So the degree on the top is heavier, bigger than the degree on the bottom. If that is the case, then our horizontal asymptote will be none. We will not have a horizontal asymptote, okay? The second case that we're going to look at is if the degree on the bottom is higher. Okay, so let's just figure out what our degree of the numerator. The degree of the numerator, well, there's only one term. The degree is the exponent of my x term. So my n in this case equals 1. Now in my denominator, which term am I going to look at? Which has a higher exponent? Well, this x has an exponent of 1. This negative x to the 4th has a degree of 4. So obviously the 4 is greater. So my d equals 4. And this is the case where this time n, the degree of the top, is less than the degree of my denominator. Okay, this is bottom heavy. And in this case, we will get y equals 0 as our horizontal asymptote. Okay, last but not least, is, well, what if the term in the top, the degree of the top, is equal to the degree of the denominator, okay? So hopefully you can see here that the degree of the top is this x squared term, so my degree is 2 on both the top and the bottom. So in this case, n, where the degrees are the same on the top and bottom, then the answer is going to be my coefficients of the terms, okay, that have the highest exponents. So in this case, my horizontal asymptote would be y equals, and it's going to be the coefficients of these two terms, 4 divided by 2, which is 2. That's how we find the horizontal asymptote, okay? All right, and these rules you need to memorize, okay? Now, how do we find the x-intercepts and the y-intercepts? It's the same as any other function. If you wanted to find the x-intercept of a linear function, what would you do, okay? Remember, x-intercept means that y equals 0. So when we're solving for an x-intercept, we're going to set the numerator equal to 0 and solve for x. To find the y-intercept, we're going to substitute 0 in for x and solve for y. Go ahead and pause the video, make sure that you've copied all of these rules down and that you understand, okay? And next are some examples. Okay, so let's work through an example. We're going to fill out this table, so you can just write these problems beneath the columns that you wrote with the rules. Okay, first of all, f of x equals 3x squared over x minus 2. Now, the degree of my numerator is, remember it's the exponent, the degree of my numerator is that 2 right there. And the degree of my denominator is 1, okay? So, in this case, we have top heavy, okay? N is greater than D. If the graph is top heavy, look back at your rules. That means that the horizontal asymptote, there is none. Vertical asymptote. Look back at your rules. How do we find vertical asymptotes? We set the denominator equal to 0 and solve. Okay, well my denominator is x minus 2. I set it equal to 0. That means I have a vertical asymptote at x equals 2. X-intercepts. How did I find x-intercepts? I set my numerator equal to 0 and solve. Well, we have 3x squared equals 0 if I divide 3 by both sides, right? And then take the square root of both sides. Hopefully you can see that we get x equals 0. And finally, the y-intercept. Remember, wherever we see a 0 in our original function, wherever we see an x in our original function, okay, you are going to put a 0. So I've taken this function called f of x, y, and wherever I saw an x, I put a 0. Okay? Now, if I simplify this, 3 times 0 squared, well, 0 squared is 0 times 3 is 0. Now, what do I get in the denominator? 0 minus 2. Doesn't matter what I get in the denominator as long as it's not 0. Okay? If we divide these two out, 0 divided by anything is going to be y equals 0. So we'll see that we have a y-intercept at 0. Now, if we look at the graph of number 1, can we verify that the information that we found was correct? Yes, we have a vertical asymptote at x equals 2. It does look a little bit different, okay? However, we do have an x-intercept and a y-intercept at x equals 0, and y equals 0, and there is no horizontal asymptote. What I want you to do now is pause the video and work out the answers to numbers 2 and 3, okay? Alright, and we're back now. I'm going to show you the answers. Okay, on number 3, you need to find the simplified form. Bring these answers to class, as well as any questions. See you tomorrow.